Good day, learners. Welcome to our physical sciences lesson. My name is Amenem Kize. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with the Gauteng Department of Education. Right, grade 11s, our focus today is on knowledge area chemical change. Then the topic under chemical change will be redox reactions. So it's what we are going to focus on for today. Right, grade 11s, as per your ATP or as per your examination guidelines, this is what you need to know under redox reactions. One, it should be what oxidation numbers of atoms in molecules, explain the meaning of oxidation number, assign the oxidation numbers to atoms in various ions and molecules, and also describe a redox reaction, identify redox reactions and apply the correct terminology to describe all the processes, oxidation numbers, define oxidation actually and reduction in terms of electron transfer and also in terms of oxidation numbers, define the reducing agent, the oxidizing agent, and also balance the redox reactions by using half reactions from the table of standard reduction potentials. So this is what you need to know as what are grade 11s under redox reactions. Right, so grade 11s, let's start with the oxidation numbers. What is an oxidation number? So moving forward, you'll see how important, to be able to assign oxidation numbers correctly. So what is an oxidation number? So an oxidation number of an atom in a molecule or ion is the charge that the atom can have or has should all the compounds be regarded as ionic, right? So let me repeat that. The oxidation number of an atom in a molecule or ion is the charge that the atom can have or has should all compounds be regarded as ionic. So that is the oxidation number. Right, if you still remember from grade 10, you did, talk a lot about, the periodic table. So what I want us to look at here, this is our periodic table. Right, so for example, your elements in group 1, the charge, it's what I want to talk about here because it's going to assist us a lot, just to remind you of what you did in grade 10. So the charge for elements in group 1, I think you still remember that, is positive 1, and then in group 2 is positive 2, and then I'm having group 3 or Roman figure 3, which is group 13. This one, so here we're having plus 3, and then here is plus or minus 4, right? And then for elements in group 15, the charge after they've gained, it's negative 3. Here we have negative 2 for elements in group 16, and then for elements in group 17 we're having negative 1, and then for elements in group 18, which are your noble gases, it's the charge there is 0. So it's what I just want to remind you. It's what you did in grade 10. So the charge, after they've lost an electron, the elements in group 1, they become positively charged, right? And then the charge there is positive 1 for group 1, and then for group 2 is positive 2, and then for group 3 is positive, or group 13, it's positive 3, and then for group 14 plus or minus 4. Group 15 is negative 3, group 16 is negative 2, and then the charge for group elements in group 17, your halogens, it's negative 1, and then those in group 18, which are your inert or noble gases, it's 0. So I hope you still remember this because it's going to assist us a lot when it comes to, assigning the oxidation numbers, right? Then what is the use of oxidation numbers, right? So one, the use of oxidation numbers. Oxidation numbers provide information on the movement of electrons during a chemical reaction. So they provide information on the movement of electrons during a chemical reaction, right? So for example, if there's an increase in oxidation number, it means that for that atom, that atom is it's losing electrons, right? And then, but if there's a decrease in oxidation number of that atom, then that atom is gaining what? Electrons. So oxidation numbers, so they provide information on the movement of electrons during a chemical what? Reaction. So they provide information on the movement of electrons during a chemical reaction. If there's an increase in oxidation number, the atom is losing electrons, but if there's a decrease in oxidation number, then that atom is gaining what? Electrons. So that is the importance of what? Of oxidation what? Numbers, right? So these are the rules, grade 11. So these, you should know these rules. So these are the rules that you have to follow when you are assigning the oxidation numbers of atoms, right? So one, each atom in a pure element has an oxidation number of 0, right? So that is very, very important, okay? So each atom in a pure element has an oxidation number of what? Of 0. For example, the oxidation number of iron in iron metal is what? Is 0. The oxidation number of what? Iodine in an iodine molecule is also 0. And then the oxidation number of sulfur in what? In S8 is what? Is also 0. So when it comes to a pure element, if an element is on its own, right, is not mixed with any other what element or any other atom, so you should know that its oxidation number is going to be what? 0. So let's not forget that, okay? Then in a monoatomic or in monoatomic ions, mono means 1. So in monoatomic what? Ions, the oxidation number equals to the charge. The oxidation number equals to the charge on what? On the ion, right? So for example, the oxidation number of a hydrogen ion is going to be what? +1, right? And then the oxidation number of chloride what? Ion is going to be negative what? -1, right? So that is rule number 2. But for pure elements, right, for an atom in a pure element, you should know that the oxidation number is going to be 0. But for mono atomic ions, the oxidation number is equals to the charge on what? On the ion. For example, when you look at what? A hydrogen what? Ion, the oxidation number will be +1. Chloride ion, the oxidation number will be what? -1. So we can even give more examples, maybe for rule number what? Rule number 2. If you have Mg2+, this is magnesium ion. So what will be the oxidation number of magnesium ion? It will be what? +2, right? So O2 minus, this is oxide what? Ion. So what is the oxidation number of this oxide ion? It is going to be what? -2. So it's what they're trying to say here when it comes to what? Rule number 2, right? So then let's move on. So elements of group 1, group 2, and group 3 form positive ions of which the charge is equal to what? To the group number, right? So let me repeat that. Elements of group 1, group 2, and group 3 form positive ions of which the charge is equals the group what? The group number. So it's what I was talking about when it comes to this periodic what? Table. So for example, these are elements in group 1, this is group 2, and then this is group 3, right? So you can see they form positive what? Ions, right? So their oxidation number will be equals to what? This charge. For example, if you have H+, it will be +1. If you have Mg2+, then the oxidation number will be +2. And then if you have Al3+, then the oxidation number will be what? +3 or 3+, right? So it's what they're trying to say here. That is actually rule number 3, right? Then so here they've given you the examples. So this is magnesium. So magnesium here, it's in group 2, and then after it has lost protons, sorry, not the protons, but the electrons, it will be what? Mg what? 2+, right? So which means that its oxidation number will be what? 2+ or +2, all right? Then fluorine always has an oxidation number of -1 in compounds. So let's not forget that, right? So fluorine, so when you look at fluorine, is in group 17. So remember, elements in group what? 17, their charge is -1, right? So what we need to know for fluorine when it is in what? In a molecule, it's or in a compound, its oxidation number is always going to be what? -1. So it's what they're trying to say there. So for example, maybe for you to understand better, if you have a compound or a molecule HCl, right? So not HCl, I want to say HF, right? So let's erase this, HF. So the oxidation number of fluorine there will be what? Will be -1. So it's what they're trying to say. So fluorine always has an oxidation number of -1 in what? In compounds. But if it's on its own, right? For example, when you have F2, remember it's a diatomic molecule. So what is its oxidation number? Remember, it's an atom in a pure what element, right? So its oxidation number here will be what? Will be 0. But in a compound, HF, for example, its oxidation number will be what? -1. So I hope you'll see the difference here. They are not saying it is always equals to, -1, even if it's on its own, right? So if it's on its own, remember, it's an atom what in a pure what element, right? It's not mixed with any other atom or different what atom, so its oxidation number will be 0. But if it's in a what a compound, its oxidation number is going to be what? -1, right? So I hope it's making sense, learners, right? Then the oxidation number of hydrogen is always +1, right? But there's an exception there, right? So the oxidation number of hydrogen is always +1, except in the metal what? Hydrides, right? So but it's always +1, except in metal what? Hydrides, ne? So an example, in a water molecule, the oxidation number of hydrogen is +1, right? And then in sodium what? Hydride, right? So in sodium hydride, it's not going to be +1, right? It's going to be what? -1, right? So yes, we understand in almost all the cases, right? The oxidation number of hydrogen is what? Is +1, but except when it comes to metal what? Hydrides. So when it comes to metal hydrides, it changes. We can see when it comes to sodium hydride. So when it comes to sodium hydride, you can see its oxidation number is no longer +1, but it's what? It's -1. So these are the rules that you need to know by heart, learners, right? So that you'll be able to assign oxidation numbers correctly, so right. Then the oxidation number of oxygen is always -2, right? Except in peroxide. For example, when it comes to peroxide, for example, when you look at your hydrogen peroxide, né? So in most cases, or in almost all the cases, the oxidation number of oxygen we are saying is -2, right? But when it comes to hydrogen peroxide, you can see it's what? Is -1. So it only differs when it comes to peroxide, but in all other compounds, its oxidation number is always going to be -2. That is oxygen, right? So it differs only when it comes to peroxide, where it is going to be what? -1. So those are the exceptions. It's like when it comes to hydrogen, you're saying hydrogen, right? Its oxidation number in almost all the cases, right? Its oxidation number is what? Is +1, right? But when it comes to metal hydrides, it changes. We can see when it comes to sodium hydride, its oxidation number is no longer +1, but it's what? Is -1. So that is the only exception, right? Same with oxygen. In almost all the cases, its oxidation number is what? Is -2, but when it comes to peroxides, it changes. For example, when it comes to this peroxide molecule or hydrogen peroxide, you can see its oxidation number is no longer -2, but it is what? -1. Right, so those are some of the rules to assign, the oxidation numbers, right? So let's continue with the rules. The oxidation numbers of halogens, your Cl, your Br, your I, are always -1, including your fluorine, right? Except, but remember, for fluorine, its oxidation number does not change. There's no exception. It's always -1. So they're saying here, except when these atoms are bonded to atoms with a higher electronegativity. It's when it's going to change. But in most cases, it's the oxidation number of halogens is negative what? 1, except when these atoms are bonded to atoms with higher electronegativity. For example, in hydrochloric acid, the oxidation number of chlorine is equals to negative 1, but when it comes to ClO minus, right, the oxidation number of Cl becomes what? Positive what? Positive 1. But in most cases, for halogens, your Cl, Br, and I, right, the oxidation number is negative 1. It only differs when they are bonded to atoms with higher electronegativity. So these are some of the rules. So let's continue again with the rules. So you need to remember these rules, learners, right? So that you'll be able to assign, you know, oxidation numbers correctly to those atoms. Ne? Right. So in neutral compounds, right, the sum of oxidation numbers of the constituent atoms equals to what? 0. For example, the sum of oxidation numbers of sodium and chlorine in sodium chloride, it's going to be 0, because when you look at sodium is in group 1, so its what charge will be plus 1, and then this Cl is in group what? 17, its charge is what? Is negative what? 1. So plus 1, negative 1, what are you getting there? You are getting 0. So the sum of oxidation numbers for neutral compounds should always be equals to 0, right? So let's not forget that. Even when it comes to how do you see that the compound is neutral, as long as you don't see, you know, what a charge, a positive charge or a negative charge, it means that that compound is what? It's neutral, right? For example, copper sulfate, right? So CuSO4, you can see there's no charge there. So when we add the oxidation numbers of those atoms there, they must give us what? 0, right? Then in polyatomic, poly means many, so or more than 1, right? So in polyatomic ions, the sum of the oxidation numbers of the constituent atoms equals to the charge on the ion, right? So what are they trying to say here, right? This is ammonium, so here is plus 1, so this is ammonium ion, right? So they are saying the sum of the oxidation numbers, right, they must be equals to plus 1, right? If I'm having SO4 2 minus, the sum of oxidation numbers of sulfur and oxygen should give me negative 2. If I'm having Cr2O7 2 minus, right? So the sum of oxidation numbers of chromium and oxygen should give us what? Negative 2. So it's what they're trying to say here. So let's check with that one of ammonium, right? So remember, the sum of the two should give us what? What is this? Positive what? Positive 1, right? So we are having what? Nitrogen, right? And then we are having what here? And remember, for nitrogen, so nitrogen, it's negative 3, right? And then hydrogen is positive 1, right? So the charge is positive 1, but how many hydrogen atoms are we having in that ammonium ion? There are 4. So it will be 4, multiply that by what? By positive what? Positive 1, right? So this actually will give us what? Positive 1, because minus 3 plus 4 will give us what? Plus 1. Same even when it comes to this one, right? So we can get the oxidation number of what? Of sulfur, ne? So it's going to be what? Sulfur plus 4 into negative 2. Not this negative 2, the one that you see there. Remember, for oxygen, what is the oxidation number of oxygen? It's always negative 2. So that's the reason why I've multiplied by negative 2 there, right? And where is this 4 coming from? This 4 it is the number of oxygen atoms that are there in that ion. So there are 4. And what is the oxidation number of oxygen? The oxidation number of oxygen is negative what? So this actually should give us what? Negative what? Negative 2. So for this to give us what? Negative 2, right? It means that this sulfur should be what? Positive what? 6, because I'm looking at positive 6 plus into minus this, right? So what should I get there? 4 times negative 2. So 4 times negative 2, it's going to be negative what? Negative 8. And what is negative 8 plus 6 is negative what? Negative 2. So that is rule number what? This rule of polyatomic what? Ions, right? So in polyatomic ions, the sum of oxidation numbers of constituent atoms equals to the charge on what? On an atom. So here they've given you what? Some examples, right? Then now let's look at how we can determine the oxidation numbers, but let's make sure that we don't follow those, we don't forget those rules to assign the oxidation numbers, because they're going to assist us here. All right, then let's look at example number 1. So they want us to determine the oxidation number of nitrogen in nitrogen monoxide. Ne? So they want us to determine what? The oxidation number of nitrogen in nitrogen monoxide, right? So how are we going to do that? So what we know is that the oxidation number of oxygen does not change, right? It's always negative what? It's always negative what? Negative 2, except when it comes to what? Peroxides. Ne? So this is not a peroxide, so we expect its oxidation number to be what? Negative 2. So that is oxygen atom, right? So what am I having here? So what is this? Nitrogen monoxide, right? So the oxygen has an oxidation number of negative 2. And then how are we going to get the oxidation number of nitrogen, right? So it's going to be what? Nitrogen plus oxygen. How many oxygen atoms are we having here? It's 1, right? And what is the oxidation number? So it's going to be 1 oxygen atom. And what is the oxidation number? Is negative what? Negative 2. And when we add the oxidation numbers here, they must give us what? 0. Why am I saying they must give us 0? Is because this is a neutral compound. You can see here, I don't have any charge. I don't have a positive charge there. I don't have a negative charge. So this should be equals to what? 0, because this is a neutral what? What compound, right? So N will be what here? Positive what? 2. So we are done, right? So that is the oxidation number of what? Of nitrogen in nitrogen monoxide, right? So this is nitrogen monoxide, or can say what? We can say nitrogen 2 what? Oxide. Okay, so that is another what? Example there, right? So example 2. They want us to determine the oxidation number of nitrogen in nitrogen dioxide, right? So it's going to be what? How many nitrogen atoms are we having there? It's only 1. So it's plus what? 2 oxygen atoms, right? You can see that, right? It's 2 oxygen atoms in 1 molecule of nitrogen dioxide. Then what is the oxidation number of nitrogen? Is negative 2. So this should be equals to what? 0, because this is a neutral what? Compound. Ne? So it's going to be what? N will be positive what? Positive 4. That will be the oxidation number of what? Of nitrogen in nitrogen what? Dioxide, right? So this is how we should use the rules to get or to assign the oxidation numbers of atoms. Ne? And then example number 3. Determine the oxidation number of sulfur in in a sulfate what? Ion. So this is SO42 what? Minus. It's a sulfate what? Ion, right? So how many sulfur atoms are we having in that sulfate ion? It's only 1. So I'll write sulfur there, plus how many oxygen atoms am I having there? It's 4. And what is the oxidation number of oxygen? Is negative what? 2. But this should be equals to what? Negative what? 2. Remember now it's an ion, right? So the total the oxidation number should give us what? -2. But if it's neutral, a neutral compound, the total of oxidation numbers, or the sum of oxidation numbers, should give us what? 0, right? So here sulfur is going to be what? Plus 6. That will be the oxidation number of what? Of sulfur, right? In a sulfate what? Ion, right? That is example number 3. So example number 4, we are given K2Cr2O7, which is potassium dichromate. So that is the name of that compound is potassium dichromate, right? So what are they looking for here? They are looking for the oxidation number of chromium in potassium dichromate, right? So potassium is in group 1. So how many potassium atoms are we having here? There are 2, right? What is the oxidation number of potassium? So potassium is in group 1, so its oxidation number would be what? Would be +1, right? Plus we are having chromium, but how many chromium atoms are we having in that one molecule of a potassium dichromate compound? So there are how many? There are 2. So I'll say 2Cr. Why 2Cr? Because there are 2 when it comes to that compound. Then plus 7, then it's 7 of oxygen atoms, and oxygen, we know its oxidation number is -2, and this should be equals to what? 0, because this is a neutral compound. So if this is a neutral compound, so here I'm going to have 2, right? And then minus 14, right? So 7 times 2 is 14, right? Or so 7 times -2 will be -14. So 2 minus 14. So I'm having what here? 2Cr, right? Minus 12, because -14 plus 2 will be what? -12. This is equals to what? 0. So I'm having 2Cr equals to +12. So now I'm transposing. So it was negative this side, then the other side is going to be what? Positive. Then I need to divide by 2, then Cr will be plus what? Plus 6. That will be oxidation number of chromium in potassium dichromate ion, right? So that was our example number number 4, right? Example number 5. Determine oxidation number. Determine the oxidation number of chromium in a dichromate ion. So a dichromate ion, it is Cr2O7 to minus. So this is what we are going to get. How many chromium atoms are we having in that dichromate ion? There are 2. So I will say 2Cr plus oxygen atoms, there are 7. What is the oxidation number of oxygen? Is -2, and this should give us what? The total of -2. I think already we have talked about this, right? So I'm having 2Cr. What is negative 2 times 7 is -14, so it's going to be -14. Then I need to transpose that -14, so the other side it is going to be what? Positive 14. Then positive 14 minus 2 will be what? Plus 12, right? So this side is going to be 12 divided by 2. Therefore the oxidation number of Cr will be equals to what? Plus 6, right? Example, determine the oxidation number of carbon in sodium carbonate. Determine the oxidation number of carbon in sodium carbonate. So the sodium carbonate, there are 2 sodium atoms, right? And sodium is in group 1, so the oxidation number will be +1, right? Plus carbon, it's what we are looking for. We are looking for the oxidation number of carbon. And then plus 3 oxygen atoms times -2, which is its oxidation number. That oxidation number is always like that, unless if we are dealing with what? With a peroxide. Same with hydrogen, it's always +1, unless if we are dealing with what? With a metal hydride. Then this should be equals to 0. It's not an ion, it's a compound, a neutral compound. Then what am I having here? Is 3 times -2 is -6, so -6 plus 2 will be negative what? So this is C, and then plus, so not plus, but it will be negative what? 4 equals to 0. So here I'm going to have what? Positive 4. So yeah, it should be what? Positive 4. So that is the oxidation number. So this was our example number 6, right? Then this is an activity. Number 1, they want you to explain the meaning of the term oxidation number, right? Number 2, what is the use of oxidation numbers? And then number 3, determine the oxidation number of the underlined atoms in those compounds or ions. Ne? So explain the meaning of the term oxidation number. So oxidation number, we have it here. So the oxidation number is of an atom in a molecule or ion is the charge that the atom can have or has should all compounds be regarded as what? As ionic. So that is the explanation of an oxidation number. So explain the term oxidation number. It is the charge that the atom can have or has should all compounds be regarded as what? As ions. Ne? So the uses of oxidation numbers is actually to track the movement of electrons during a chemical reaction. So that is the most important, use of oxidation numbers, right? So it is just there to assist us to track the movement of electrons during a chemical reaction. So when we use oxidation numbers, we'll be able to tell which atom is losing electrons, which atom is gaining electrons. Remember, the one that gains, right? There must be a decrease in oxidation number. The one that loses electrons, there must be an increase in what? In oxidation number. So that is how oxidation numbers assist us to track actually the movement of what? Of electrons actually in what? In a chemical reaction. Right. Now let's look at again finding the oxidation numbers of those compounds, or the underlying, not compounds, but the underlying atoms in those compounds, right? So 3.1 learners, you are given phosphoric acid. So this is phosphoric acid. The chemical name, the chemical formula is H3PO4, right? So they want us to get the oxidation number of phosphorus in phosphoric acid. Ne? So I'm having H3PO4, right? So this one is the one that is underlined. So it's going to be what? 3 times positive 1. There are 3 hydrogen atoms, and then the charge of hydrogen, or the oxidation number of hydrogen, it's going to be what? Plus 1, plus phosphorus, which is what we are looking for, plus 4, plus 4 oxygen atoms, and then the oxidation number of oxygen is negative 2, and this should give us what? 0. So by now you understand why it should give us 0. We are dealing with what? With a neutral compound. Ne? Then I'm having 4 times negative 2 is negative 8. So what is negative 8 plus 3? Negative 8 plus 3 is going to be what? Plus what? It's going to be negative what? 5. Ne? So I'm having P minus 5 equals to what? 0. So P will be positive what? Positive 5. So that is our 3.1. Okay. Then 3.2, it's Fe2O3. So Fe2O3. So the chemical name here will be iron 3 oxide. Ne? So it's iron 3. That is why we see a 3 there. So it's going to be what? Iron 3. Iron 3 oxide. Right. So they're looking for what? Oxidation number of Fe. Right. So let's check. So how many Fe atoms is 2? Right, so I'll just say 2Fe because I'm looking for the oxidation number of it, plus 3 and into negative 2 equals to what? 0, right? So it's going to be 2Fe equals to what? 3 times negative 2 is negative 6 transpose. Then we have what? Positive 6 divided by 2 divided by 2. Therefore, the oxidation number of ion in oxide is going to be what? Plus 3. Okay? That is our 3.2. Then our 3.3, we are given sulfuric acid. So 3.3, I'm having sulfuric what? Acid. They're looking for the oxidation number of sulfur in sulfuric acid. Ne? So it's 2 times positive 1. There are 2 hydrogen atoms. The oxidation number of hydrogen is what? Is 1 or plus 1 plus sulfur plus 4 into negative what? Negative 2. This should give us what? 0. By now we understand why it should be 0, because we are dealing with what? With a neutral what? Compound. Ne? So I'm having 2. 4 times negative 2 is negative 8. So negative 8 plus 2 is going to be what? Negative 6. So sulfur minus 6 equals to 0. Then sulfur is going to be what? Plus what? Plus 6. That will be the oxidation number of what? Of sulfur. I hope, learners, we are still together. Let's move to 3.4. So 3.4 is Al3O3, right? So Al3, it can be Al3O3. It should be, so it's a mistake here. It should be Al2O3, yes, not Al3. Sorry about that. So it's aluminium what? Oxide. Ne? So this aluminium what? Oxide. So they're looking for oxidation number of aluminium in aluminium what? Oxide. Al2O3. So it's going to be 2Al, right? Because there are 2 aluminium atoms, plus 3 into negative 2. This should be equals to what? 0, right? So it's going to be 2Al equals to what? Positive 6, because on your left you had negative 6. So then transpose, then we're going to have what? Positive 6 divided by 2, divided by 2. Therefore, the oxidation number of aluminium will be what? Plus 3. I hope it's making sense. Yeah? Right. So that is our 3.4. Right. So now let's move to our 3.5. So we are having H2SO3. H2SO3, which is going to be what? Sulfurous acid. The previous one, 3.3, we have sulfuric, right? And then 3.5, you're having sulfurous what? Acid. So what is the oxidation number of sulfur in sulfurous acid? So I'm having 3.5, which is H2SO3. Ne? So they're looking for oxidation number of sulfur there. So it's 2 into plus 1 plus sulfur plus 3 into negative 2. This should be equals to 0. So when you add all those oxidation numbers, they must give us 0. This is the neutral what? Compound. Ne? So for sulfur, so 3 times negative 2 is negative 6. So what is negative 6 plus 2? I'm having what? A negative what? 4. So it's minus 4 here equals to 0. Then sulfur is going to be what? Plus what? Plus 4. That will be the oxidation number of sulfur in sulfurous what? Acid. So I hope, learners, you are following. I'm not doing this on my own, right? So I hope as much as I'm the one who's doing it, but I hope you are following. You are able to see what you are supposed to do, right? Then 3.6. So for you 3.6, right? 3.6, it's nitric acid. They're looking for the oxidation number of what? Nitrogen in nitric what? Acid. Okay, so hydrogen, there's only one hydrogen, so I'll just say 1 times positive 1. This positive 1, remember, the charge or the oxidation number of hydrogen. Ne? So plus nitrogen plus 3 into negative 2. This negative 2 is the oxidation number of oxygen, and this should be equals to what? 0. Right, so for nitrogen, I'm having negative 2 times 3, which is negative 6, plus 1, which is going to be what? Negative 5. Then this side, I'm going to have what? Positive what? Positive 5 for nitrogen. So that is the oxidation number for nitrogen in nitric acid. Ne? Then 3.7. So for 3.7, you are given the manganese. Let me just confirm. You are given the manganese ion. Not manganese, but permanganate what? Ion. Sorry about that. You are given the permanganate what? Ion. Right. So they are looking for the oxidation number of manganese in permanganate what? Ion, right? So I'm having MnO4 minus, so it's just Mn there plus 4 into negative 2. this should be equals to what? -1, right? So it should be equals to that charge. Ne? Then I'm having Mn, which is your manganese. 4 times -2 is -8. Then transpose that -8 to the other side is going to be +8. So +8 minus 1 is positive what? 7. That will be the oxidation number of manganese in permanganate what? Ion. Then let's look at 3.8. 3.8, right? 3.8, you are given NO2 plus, ne? NO2 plus, right? So if it's NO2 plus, right, it's N, so they're looking for oxidation number of nitrogen, so plus 2 into -2, this should be equals to what? 1, right? So because I'm having plus there, right? So it's going to be N equals to 1. 2 times -2 is -4. Then transpose that -4 to the other side. I'm having what? A +4. So it's plus 4. Then here is going to be what? Plus what? Plus 5. Ne? So that will be the oxidation numbers, right? So, but let's not forget, for atoms in pure elements, right, the oxidation number is going to be what? 0. So I can even include this 3.9 and talk about Br2. Br2, its oxidation number is going to be what? 0, because it's not mixed with any other what element, so it's on its own. So its oxidation number is also going to be what? 0. All right. Then now let's look at the redox reactions, right? So what is the redox reaction? So we have talked about what the oxidation oxidation numbers, the rules to assign oxidation numbers, and also the examples of how to determine the oxidation numbers of atoms in ions or in molecules, right, or compounds. Ne? Right. So let's start with the definition of electrochemistry. Right, so electrochemistry is the branch of chemistry that deals with transformation between electrical energy and chemical what? Energy, right? So we'll talk more, we'll understand this better when it comes to, you know, those two types of electrochemical cells, your galvanic cell and your electrolytic cell. So from next day onwards in grade 11, you'll be doing your what? Your galvanic cell, right? So, but not the electrolytic, so it's just galvanic. So you'll understand when we talk of electrochemistry that indeed it is the branch of chemistry that deals with the transformation between, you know, electrical energy and chemical what energy. But for now, our focus is redox what? Reactions. So electrochemical reactions or redox reactions, right? So what is a redox reaction? So a redox reaction is a reaction where there's transfer of what? Of electrons, right? So let's not confuse that with acid-base reactions. So acid-base reactions, it's a reaction where there's transfer of protons, right? But here, when it comes to redox reactions, those are reactions where there's transfer of what? Of electrons. And how do we track the transfer of electrons? Right, we use oxidation what numbers. Hence, we were looking at those rules and also some examples on how to determine, you know, the oxidation number of an atom in an ion or in what? In a molecule or a compound. Yeah? Right. So, reduction and oxidation. In terms of electrons, reduction and oxidation can be defined as follows. Right, so, but we have defined what a redox reaction. A redox reaction is a reaction where there is transfer of electrons. So maybe again, just to explain to learners, where is this redox name coming from, right? So redox, RED stands for reduction, and then OX stands for oxidation. So if they say redox reactions, it's like they're saying reduction oxidation reactions. Ne? So RED is reduction, OX is oxidation. So redox reactions is the same thing as saying reduction oxidation what? Reactions. But what is a reduction oxidation reaction or redox reaction? Is a reaction where there's transfer of what? Of electrons, right? So Then now let's focus on what reduction oxidation. But when you talk of reduction oxidation reaction or redox reaction, it's a reaction where there is transfer of what? Of electrons, right? So reduction oxidation, we can define reduction and oxidation in terms of electron transfer, and also define oxidation and reduction in terms of oxidation numbers, right? So in terms of electron transfer, what is reduction? Reduction is a gain of what? Of electrons. So it's when electrons are what? Are gained. Ne? And then oxidation is when electrons are what? Are lost. But according to our exam guide, reduction is gain of electrons, and then oxidation is loss of what? Of electrons. So this one is gain of electrons, and then here loss of electrons. So that is how we can define oxidation and reduction in terms of electron transfer, right? Then another thing which is important here is that when it comes to a redox reaction, reduction always go together with oxidation, right? So when it comes to a redox reaction, there are two half reactions. There's reduction, there's oxidation, okay? So we are going to talk more about that moving forward. So they occur simultaneously, right? So when it comes to what a redox what reaction, but for now, understand what is redox, understand what is reduction, what is oxidation in terms of what? Of electron what transfer. Then in terms of oxidation numbers, then when it comes to reduction, there's an increase in what? There's a decrease in oxidation number, and then when it comes to oxidation, there's an increase in what? In oxidation number. So please, learners, be careful, right? How are you going to tell that an element or an atom is losing electrons? If its oxidation number increases, right, it means that what substance or that atom is losing what? Electrons. But if its oxidation number decreases, you'll see that moving forward. But if its oxidation number decreases, it means that that atom is gaining what? Electrons, right? So the electrons are gained if there's a decrease in oxidation numbers, and then electrons are lost if there's an increase in what? In oxidation number. So let's not forget that, learners. So we have defined redox, we have defined reduction oxidation in terms of electron transfer. We have also defined redox, what is this? Reduction and oxidation in terms of oxidation numbers, right? Then now let's look at oxidation states and redox reactions. Okay, so what is going to assist you to identify whether the reaction is it's a redox reaction or not, ne? Is the oxidation numbers, right? So if the oxidation number changes, it means that reaction, it's going to be what? A redox what? Reaction. There is transfer of electrons there. But if the oxidation number does not change, right? If the oxidation number does not change, you can't say or you can conclude by saying that the reaction is what? It's a redox what? Reaction. So a redox reaction, remember, there's transfer of electrons. How are you going to see that there's transfer of electrons? The change in oxidation number. So if the oxidation number changes, either the oxidation number of an atom is increasing or decreasing. But as long as there's that change in oxidation number, it means that electrons are being transferred from one atom what? To the next atom. So that reaction obviously is going to be what? A redox what? Reaction. Okay. Then, so the oxidation state of an atom signifies the number and the sign of the charge the atom will have in a molecule if bonding electrons transferred completely, right? Then if the oxidation number of an element increases during a reaction, then the element is oxidized during the reaction. But if the oxidation number decreases, then the element is what? Is reduced. That is another thing which is very, very important, right? So how are you going to tell that there is loss of electrons, right? There is an increase in oxidation numbers. How are you going to tell that there's gain of electrons? There will be a decrease in oxidation number. How are you going to tell that there's there's loss of what? Of electrons? There will be an increase in what? In oxidation number. Then now, let's talk about what the substances. learners, what is important here, I don't want you to get confused here, right? When you talk of reduction, when you talk of oxidation, actually we are talking about what? The reactions, right? Those are the reactions, right? That occurs during what? A redox what? Reactions. So that is reduction and what? And oxidation. So those are reactions. Those are not substances. So when they talk of reduction, they are not talking about the substance, but they're talking of what? Of a half reaction or a reaction, right? If they're talking about oxidation, they're not talking about a substance, right? Or an atom, right? But they're talking about what? A reaction. That is very, very important, okay? So actually, the way we have defined reduction and oxidation, we're supposed to say it's a reaction, right? That is reduction. We're supposed to say it's a reaction, right? Where what, or it's a half reaction, where there is what there is a decrease in what? In oxidation number, right? Or when you talk of oxidation, it's a reaction, right, where electrons are lost, right? Or it's a reaction where there's an increase in what? In oxidation number. I hope it's making sense, né? Oxidation, reduction, those are reactions, right? Although when we define, we don't say it's a reaction, but you should know that those are reactions. We just say reduction, gain of electrons, oxidation, loss of what? Of electrons. But reduction, oxidation, those are reactions. So reduction, there is that is the reaction where there is gaining of what? Of electrons. Oxidation, that is the reaction where there is loss of what? Of electrons. Now let's move to atoms now, or to substances. Now we are talking about a substance now, right, that loses electrons, a substance that gains electrons, right? I hope it's making sense. So I don't want you to confuse those two. Reduction, it's a reaction. Oxidation is the reaction. But now when you talk of a substance that is oxidized, a substance that is reduced, now we are talking about atoms. We are not talking about the reaction, right? So now what is important here, né? If there's an increase in oxidation number for that atom, right? So the oxidation number of an atom increases. It means that that atom, it's what they're saying here, that atom is being what? Is being oxidized. It loses electrons. Let me repeat. If there's an increase in oxidation number of that atom, right, it means that an atom is being what? Oxidized. So that atom is losing what? Electrons, right? But if there's a decrease in oxidation number of that atom, right, so that atom is being reduced, or that atom gains what? Electrons. Right? So I'm starting with the oxidation number, because what is going to assist us to determine whether the substance is losing or gaining electrons is the oxidation numbers, right? So if there's a decrease in oxidation number, right, that substance is reduced. So the substance is gaining what? Electrons. But if there's an increase in oxidation number, that substance is oxidized. It means that that substance is losing what? Electrons. That is very, very important. So if we talk of a substance that is being reduced, how are you going to tell that the substance is being reduced, or the atom is being reduced? Its oxidation number is going to decrease, right? Then in terms of electrons, it means that it's gaining what? Electrons. How are you going to tell that a substance is being oxidized? If the oxidation number of that substance increases, it means that the substance is being oxidized. That substance is losing what? Electrons, right? So still on what redox reactions, né? In a redox reaction, remember we said a redox reaction is the reaction where there's transfer of what? Of electrons. So in a redox reaction, electrons are being what? Transferred, né? Then there are two simultaneous half what? Reactions. So oxidation and reduction occur at the same time when it comes to a redox what? Reaction. Hence I said to you, reduction is a reaction, oxidation is also what? A reaction. So they occur simultaneously, those reactions, when it comes to a redox what? Reaction. So it's what is happening when it comes to a redox reaction. Electrons are transferred, right? So one substance is losing electrons, the other substance is gaining what? Electrons. So the two reactions, they occur at what? At the same time, right? Reduction and what? And oxidation. So the two half reactions produce the total or the net redox reaction. We'll look at that next week. electrons are lost during the oxidation half reaction, right? And then electrons are gained during the reduction half what reaction. So you can see here, oxidation half reaction, that is the reaction where electrons are what? Are lost. Reduction half reaction, that is the reaction where electrons are what? Are gained. How are we going to tell that the electrons are gained? There will be an increase in oxidation number, there will be a decrease in oxidation number, right? How are we going to tell that electrons are lost? There will be an increase in oxidation what? Number. Then, this is where we are now. Already, we have talked about the substance that is being oxidized, the substance that is being reduced. How are you going to tell that a substance is being oxidized, right? There will be an increase in oxidation number of that substance, right? So that substance is being oxidized. In other words, it means that the substance is what? It's losing electrons, right? And that substance that is being oxidized, or a substance that loses electrons, it has a specific name. We say it is what? A reducing what? Agent. Okay? So a reducing agent is the substance that is being oxidized, or a substance that loses what? Electrons. Okay? Then we have the oxidizing agent, right? So if a substance is being reduced, right, it means that the substance is gaining what? Electrons. So what is the specific name for that substance? We say it is what? The oxidizing what? Agent. So reducing agent, it's a substance that is being oxidized, or you can say it's a substance that loses what? Electrons. So do not confuse reduction with reducing agent. Reduction is half reaction where electrons are gained. Reducing agent is a substance that is being oxidized, or a substance that loses what? Electrons, right? Oxidizing agent, it's a substance that is being reduced, or a substance that gains what? Electrons. So learners, you are not going to confuse oxidizing agent with oxidation. Oxidation is the half reaction where there's loss of electrons. Oxidizing agent is a substance that is being reduced, or a substance that gains electrons. So you can see there's a difference there. And reduction, oxidation, those are half reactions, right? Or those are reactions. But when it comes to reducing agent, oxidizing agent, those are substances. So oxidizing agent is being reduced, so it gains electrons, right? Reducing agent is being oxidized, therefore it loses what? Electrons. How are you going to tell that it has lost electrons? You will look at the oxidation number. If there's an increase, then it has lost electrons, so it's being oxidized, therefore it becomes the reducing agent. Okay, then oxidizing agent, we are saying it is being reduced. How are you going to tell that the substance is being reduced? There will be a decrease in oxidation number of that substance. Okay, and if there's a decrease in oxidation number, what does that tells us? It means that the substance is gaining what? Electrons. And the substance that gains electrons, we say it is what? The oxidizing what? Agent. I hope it's making sense. So please, I know in most cases, learners, they confuse oxidation with oxidizing agent. Ne? And then reduction with reducing what? Those, from now on, you should know, those are two different things, right? Reduction is not a substance, but it's a reaction. But reducing agent is a substance, is not a reaction. That is very, very important. So learners, make sure that you don't confuse the two. Okay? So we don't want a situation where we say, give us the oxidation half reaction, and you are giving us a substance, not a reaction. Give us the reduction half reaction, you are not giving us a reaction, but you are giving us what? A substance. Give us the reducing agent, we are giving us a reaction. Give us an oxidizing agent, you are giving us what? A reaction. Because it means you didn't understand that there is a difference between those two. All right? So reduction, that is a reaction where there's gain of electrons. Oxidation, that is the reaction where there's loss of electrons. Reducing agent is a substance that is being oxidized, or a substance that loses electrons, right? Oxidizing agent is a substance that is being reduced, or a substance that gains what? Electrons, right? So that is the difference between reduction oxidation with oxidizing agent and the reducing what? Agent. Ne? So this is an example of what? Of a redox what? Reaction. So a redox reaction, let's not forget, when it comes to a redox reaction, there is transfer of what? Of electrons, right? By now, it's easy to tell that there's transfer of electrons or not. we are going to look at what? The oxidation numbers, right? So that is why we started with what? The rules, and also how to determine the oxidizing, the oxidation numbers. Okay. So let's look at this reaction. It's just a hypothetical reaction. I'm having A plus B here to produce A plus, right? And also B what? B minus, right? So remember, when it comes to those rules, we did mention that if an element is on its own, right, you can see it's just A there, right? So its oxidation number is going to be what? 0, right? Same with B, the oxidation number is what? It's 0, right? And this is a charge, so the oxidation number is going to be what? +1. Here, the oxidation number is going to be what? -1, okay? So in this, you can tell that here there's transfer of what? Of electrons. Why am I saying there's transfer of electrons? Look at the oxidation number. It changes, right? For one substance, it's increasing. For the other substance, it's what? It's decreasing, right? So let's look at A. Is the oxidation number increasing or decreasing when it comes to A? So it's from 0 to 1. So there's an increase. So there's an increase here. You can see there's an increase in oxidation number from 0 to 1. So there's an increase here for A. Okay? So there's an increase, right? Let's look at B. So 0 to -1, right? So from 0 to -1, there's a decrease in oxidation number. Decrease in oxidation number. Increase in oxidation number. Right. So for A, there's an increase in oxidation number, and then for B, there's a decrease in oxidation number. So as long as the oxidation number changes, right, it means that electrons are being transferred from one substance to the next. So that reaction is going to be what? A reduction oxidation reaction, or a redox what? Reaction. Okay, so in this reaction, we can talk about what? Reduction. We can talk about what? Oxidation. We can talk about the reducing agent. We can talk about what? The oxidizing what? Agent. Yeah? So we'll talk more about the reactions. So our focus today is to determine what, or to identify what? The reducing agent and the oxidizing what? Agent. The substance that is being reduced and the substance that is being what? Oxidized. Okay, so between A and B, which substance is the oxidizing agent? Which substance is the reducing agent? Okay, so let's check for A. You can see for A there's an increase in oxidation number. If there's an increase in oxidation number, right, it means that a substance is being what? Oxidized, right? And if a substance is being oxidized, it means that the substance is losing what? Electrons. So the substance that loses electrons, or a substance that is being oxidized, it becomes our reducing what? Agent. It becomes our reducing what? Agent, or a substance that is being what? Oxidized. Or we can say it loses what? Electrons. So A loses electrons, A is being oxidized, A is the reducing what? Agent. Let's look at B. B, you can see for B, there is a decrease in oxidation number. So if there's a decrease in oxidation number, it means that a substance is being what? Reduced, right? So if a substance is being reduced, it means that it's gaining what? Electrons. And a substance that is being reduced, or a substance that gains electrons, that substance is the oxidizing what? Agent. So oxidizing what? Agent. This is just a hypothetical what? Reaction. So oxidizing agent, or we can say a substance that is being reduced. And if we say a substance is being reduced, so it means that the substance here, it's what? It's gaining what? Gaining electrons. Right. So this is our redox reaction. I can prove why I'm saying it is a redox reaction. You can see there's transfer of what? Of electrons. And these electrons are transferred from A to B, right? So from A to B. Remember we said for A, there's an increase in oxidation number, which means that A is losing what? Electrons, or it's being what? Oxidized. For B, there's a decrease in oxidation number. It means that B is being reduced or is gaining what? Electrons. So, but where are those electrons coming from? The electrons are not coming from heaven or from the atmosphere, but they're coming from one substance to the next. So, electrons are coming from A to what? To B, or they're transferred from A to what? To B. So that is very, very important. So if one substance is losing electrons, the other one is going to do what? To gain what? Those electrons. It's like even when it comes to your acid-base reactions. Remember, acid-base reactions, those are reactions where there's transfer of protons. So if one substance is losing a proton, the other one is going to do what? To gain a proton. Same thing here. It's just that here it's no longer protons, it's electrons. There's a substance that is losing electrons, which is going to be what? The reducing agent. And there's a substance that is going to gain those electrons, which is going to be what? The oxidizing what? Agent. That is very, very important, learners. So this is the redox what? Reaction. So there's transfer of electrons from this substance to the next, from reducing agent to the oxidizing what? Agent. So in this reaction, we can also talk about what? Reduction. We can also talk about what? Oxidation, right? So, but for now, I don't want to confuse you. I don't want us to focus on the reactions. Oxidation have reactions and reduction have reactions. But our focus here is just to be able to identify that, okay, this reaction is a redox reaction. This is the oxidizing agent. This is the reducing what? Agent, right? Using the oxidation numbers, right? Then, so these are the definitions. Oxidizing agent, already I've talked about that. Oxidizing agent and the reducing agent. So as per your ATP or exam guideline, this is how we have to define the reducing agent and the oxidizing agent. So your reducing agent, please do not confuse oxidation with what? Oxidizing agent. Reduction with reducing agent. So those are two different things. So please make sure that you understand that reduction, oxidation, those are reactions. Oxidizing agent, reducing agent, those are atoms or substances. That is very, very important. Okay, right. So what is the reducing agent? A reducing agent, as per your exam guide, a reducing agent is a substance that is being oxidized, or a substance that loses what? Electrons, or whose oxidation number increases. Okay, so if there's an increase in oxidation number, right, it means that the substance is losing what? Electrons. And if the substance is losing electrons, we say the substance is being what? Oxidized. I hope it's making sense, right? If there's an increase, we start with the oxidation number, right? If there's an increase in oxidation number, it means that the substance is losing electrons. And the substance that loses electrons, we say the substance is being what? Oxidized. And the substance that is being oxidized is called the reducing what? Agent. Okay? If there's a decrease in oxidation number, right, it means that a substance is gaining what? Electrons. And the substance that gains, we say a substance is being what? Reduced. And the substance that is being reduced is called the oxidizing what? Agent. So let's not forget that. So that is reducing agent and the oxidizing what? Agent. Ne? So now we have another activity here where we have to do something. Ne? So define the following terms: oxidation in terms of electron transfer, reduction in terms of electron transfer, reduction in terms of oxidation number, and oxidation in terms of oxidation number. So grade 11s, please be careful. When it comes to oxidation, a question cannot just say define oxidation. A question cannot just say define reduction. But a question can say define oxidizing agent, and a question can say define reducing agent, right? They can say define reducing agent, define oxidizing agent, but they cannot say define oxidation. They have to say define oxidation in terms of electron transfer, or define oxidation in terms of oxidation number. I hope it's making sense. Ne? So they cannot just say define oxidation, because you'll get confused whether you should define it in terms of electron transfer or in terms of oxidation number. But if they say define oxidizing agent, you can't get confused, right? So oxidizing agent is a substance that is being what? Reduced, or a substance that what gains electrons, or a substance whose oxidation number decreases, right? Then what is this? Reducing agent is the substance that is being what? Oxidized, or a substance that loses electrons, or the substance whose oxidation number increases. But when it comes to oxidation reduction, they have to be specific, whether you should define it in terms of electron transfer or in terms of oxidation number. So just a reminder, oxidation in terms of electron transfer, here remember there is what? Loss of electrons. Okay, reduction in terms of electron transfer, gain of electrons. Simple. Reduction in terms of oxidation number, decrease in oxidation number. Oxidation in terms of oxidation number, increase in oxidation number. Okay, then for each reaction below, identify the oxidizing. So this is our last activity. So for each reaction below, identify the oxidizing agent and the reducing agent. So oxidizing agent, remember, is a substance that is being reduced, and then reducing agent is a substance that is being what? Oxidized. How are you going to tell whether the substance is being reduced or oxidized, or a substance is gaining electrons or losing electrons? You use oxidation numbers. If there's an increase in oxidation number, the substance is losing electrons, is being oxidized, it is the reducing agent. If there's a decrease in oxidation number, the substance is being reduced, right? The substance is gaining electrons. A substance, it is what? The oxidizing what? Agent. Yeah? Right, let's look at 2.1. We're having Cu2 plus, that is not copper, but that is copper 2 ion, because we have copper 1. You'll see when we are dealing with what table 4A, 4B, you'll see that there's copper 1, there's copper 2, which is very, very important to be specific. Which copper ion are you talking about? Because we cannot just say copper ion. Which copper ion are you talking about? So this one is copper 2 ion. So it's copper, the name copper 2 ion. This is zinc metal, or just zinc. This is copper metal. Right? This is zinc ion. We can't say zinc 2. We don't have any other zinc ion except this one. So this is zinc ion. Right. So now let's check which substance is gaining electrons, which substance is losing electrons. Right. So let's look at the oxidation number of copper there. So you can see this side is 2, this side is 0, right? Because it's on its own, you can see there, right? So the oxidation number of copper there is 0. So you can see it's 2 to 0. Okay? There's a decrease in oxidation number. Right? So it's plus 2 to 0. So there's a decrease. So if there's a decrease, then for 2.1, Cu2 plus becomes our oxidizing agent. Why am I saying oxidizing agent? You can see there's a decrease in oxidation number. If there's a decrease in oxidation number, it means that a substance is being reduced or a substance is gaining what? Electrons. And a substance that gains electrons, it becomes the oxidizing what? Agent. Okay? Then for zinc, it's 0 this side. The other side is what? Is 2. You can see there's an increase in what? In oxidation number, which means that Zn becomes our reducing agent. Why reducing agent? There's an increase in oxidation number. It means that it's being oxidized, is losing electrons. A substance that loses electrons is the reducing what? Agent. I hope it's clear, right? Let's move to the second one. Chlorine gas, its oxidation number would be 0. We have talked about the rules. By now you should understand why is it 0. Sodium also, it's going to be what? This side? 0. Okay? But look at this side, the side of the products is plus 1. So for sodium, there's an increase. You can see that. For sodium is 0 to 1. So there's an increase in what? In oxidation number. So if there's an increase in oxidation number, therefore Na, right, will be our reducing agent. There's an increase, it means that it's being oxidized. So it's reducing what? Agent. So look at Cl2, right? So Cl2 0, but this side is what is -1. So it's from 0 to -1. So there's a decrease in oxidation number. It means that chlorine gas here is being reduced, is gaining what? Electrons. Why am I saying it's gaining electrons? There's a decrease in oxidation number. Therefore, my Cl2, it's the oxidizing agent. All right? Let's move to the third one. Okay? Aluminum, we are assigning the oxidation numbers, which is what you should know by now, right? It's 0. And then here is +1 already, is +3 there. And then for hydrogen, it's going to be what? 0 again. The focus is aluminum and hydrogen ion, right? So one of the two will be the oxidizing agent. One of the two will be the reducing what? Agent. Yeah? So for aluminum, you can see it's from 0 to 3. 0 to 3, there's an increase in oxidation number. It means that aluminum is being oxidized. Aluminum is losing electrons. Aluminum is the reducing agent. Right? Hydrogen ion. I don't have hydrogen this side, but I'm having hydrogen ion. This side, yes, I'm having hydrogen or hydrogen gas. But this side, I don't have hydrogen. Right? So I'm having hydrogen ion. Is hydrogen ion the reducing agent or the oxidizing what agent? Let's check using the oxidation numbers. So it's from +1 to 0. So +1 to 0, there's a decrease in oxidation number. So if there's a decrease, it means that hydrogen ion is being reduced. It's gaining electrons. And the substance that gains is the oxidizing agent. It is the oxidizing agent. Okay, we are just using the oxidation numbers there. Then the last two redox reactions, these are redox. You can see this transfer of electrons. Oxidation number changes, right? So there's a transfer forward of electrons. So these two, you can see they're a bit, complicated compared to 2.1 to 2.3. So something must be done here. Right, so we are having a dichromate ion. So this is a dichromate ion. This is chloride ion. These are ions. You can see there's a charge there. This is chromium. Chromium 3 ion, 3 ion, because we have chromium 2. So you can't just say chromium ion. So there's chromium 2. You will see when it comes to the table of standard reduction potentials, we have chromium 2, you have chromium 3. All right. So then this is chlorine, not chloride. Now this is chlorine, or can say chlorine what? Gas. Okay. Now let's identify the oxidizing agent and the reducing agent. Right. So for chlorine, I hope it's clear. Not chlorine, but for chloride ion. Okay, so it's Cl minus to 0. So it's -1 to 0. You can see that. There's a decrease in oxidation. There's an increase. There's an increase in oxidation number. So when we are moving from -1 to 0, there's an increase. It means that here, Cl minus is the reducing agent. Why am I saying it's the reducing agent? There's an increase in oxidation number. It means that it's being oxidized, is losing what? Electrons. That is Cl minus. But here something must be done, right? You can see that this side I'm having oxygen, but the other side I don't have what? Oxygen. So I can't focus on oxygen because I can't track the movement of electrons there. Or I can't track whether there's an increase or decrease in oxidation number because I don't have oxygen this other side or the side of the products. Ne? But I have Cr. Even this side I'm having what? Cr. Okay. So what am I looking for? Before I can identify the oxidizing agent, the oxidizing agent, reducing agent. For this one, I have to do something. I need to find the oxidation number of chromium in dichromate ion, right? Cr2O72 minus, right? So it's going to be what? 2Cr plus 7 into negative 2 equals to negative 2, right? So 2Cr equals to 7 times negative 2 is negative 14, right? So negative 14 transpose will have positive 14, which is going to be what? Positive 12 this side. Because positive 14 minus 2 is positive 12. Divide by 2, divide by 2. So Cr will be plus what? Plus 6. That will be the oxidation number of what? Of chromium, right? In a dichromate what? Ion. So it's plus 6. So in other words here, right? Right. So there's a question here, Linus, why the oxidation number of Cl2 is 0. Go back to the rules to assign, I'm sorry to go back, Linus, but we have to, for me to be able to answer this question. Why the oxidation number of Cl2 is 0. Bullet number 1 here. Each atom in a pure element has an oxidation number of what? Of 0. So if an element is not mixed with anything, you can see, if I can say H, what will be the oxidation number? It's 0. H2 is still what? 0. Unless if I can say HCl, it can't be what? 0. So if an element is on its own, it's not mixed with any other element, right? So you can see H2 here is just 2 atoms of hydrogen, right? So the oxidation number is going to be what? 0. Cl2 is just 2 atoms of what? Of chlorine. So its oxidation number is what? Is going to be 0. So if an element is on its own, is not mixed with any other element or any other different, let me put it like that, any other different what? Element, right? Then its oxidation number is going to be what? 0. It's like if I can take about O2, O3, right? So it's still what? Oxygen. It's just that the number of oxygen atoms is no longer 1. It's what now here is 2. Here it's what? Is 3. So the oxidation number is still what? 0, because it's still oxygen is not mixed with any other different what? Element. So its oxidation number is going to be what? 0. I hope I've answered your question, right? But if now I can have HCl, we can't say it's 0 because it's now is mixed with a different what? A what? Atom, or a different what? Kind of an atom, or different what? Element. So it's where now its oxidation number will what? Will change. But if an element or as a what? An atom is on its own, is not mixed with any other, different atom, then its oxidation number is going to be what? 0. Hence, even when it comes to this one of S8, right? It's sulfur. It's just 8 atoms of what? Of sulfur. But it's not mixed with any other different what? Atom. So therefore, its oxidation number is going to be what? Is going to be 0. I hope I've answered that question. Why oxidation number of Cl2 is 0? It's because it's one of those rules, ne? The first one there on the table. Right. Okay, here we got the oxidation number of chromium in dichromate ion. We got positive 6. So here I'm having Cr2O72 minus. For me to get a total of 2 minus, it means that here I'm having Cr6 plus, right? And then, yes, for me to get a total of what? Of what is this? Of negative 2. So it means that here I'm having what? Cr6 plus what? What is this? O2 minus. So I'm having Cr6 plus and O2 minus, but how many chromium? There are 2. How many oxygen atoms? There are what? There are 7. So let's just check here. 2 times positive 6 is positive what? 12. 7 times negative 2 is negative what? Negative 14. So what is plus 12 minus 14 is going to be what? Minus 2. Okay? So now your oxidizing agent. Remember, oxidizing agent, there must be a decrease in oxidation number. So for chromium, you can see here it was Cr6 plus initial, although you didn't see that, but it's what we're supposed to find out. Ne? So it's Cr6, but this side is what is 3. You can see that it's moving from, or it's decreasing from 6 to what? To 3. So the oxidation number there decreases. So if there's a decrease in oxidation number, but remember it's the decrease in oxidation number of which ion? Cr6 plus. Okay, so which means that your Cr6 plus will be your oxidizing what? Agent. Because it's from Cr6 plus to Cr3 plus. So first thing that we're supposed to do here is to get the oxidation number of Cr, and then so that you'll be able to determine the oxidizing what? Agent. So the last one is permanganate ion. So it's permanganate ion plus SO2 to produce Mn2 plus SO4 2 minus. SO4 2 minus. So let's identify the oxidizing agent and the reducing agent. Ne? So what is the oxidation number of manganese here? Right? So the oxidation number of manganese is Mn plus 4 into -2 equals to -1. We have done this one before. So manganese will be plus what? Plus 7 in a permanganate ion. So the oxidation number of manganese in permanganate ion will be plus 7. Because this side it will be 4 times -2, which is -8 transpose, it will be positive 8. So positive 8 plus minus 1 will be plus what? Plus 7. Ne? So so it's from Mn7 plus to what? To Mn2 plus. So you can see there's a decrease in oxidation number. So Mn7 plus becomes your what? Your oxidizing agent. So now this is high order because you have to start somewhere, right? So start by getting the oxidation number. It's unlike your 2.1, 2.2, 2.3, right? But here you have to start by getting the oxidation number so that you'll be able to tell which substance here is gaining and which substance is losing what? Electrons, right? Then for oxygen, its oxidation number does not change. So here is -2, even here is also what? -2. So we can't say oxygen is the oxidizing agent or the reducing agent. Its oxidation number remains the same, right? Then now let's look at sulfur. Ne? So the one of sulfur, what is the oxidation number of sulfur here in sulfur dioxide? Right? It's sulfur plus 2 into -2 equals to 0. Why is it equal to 0? Sulfur dioxide, it's a neutral compound. Ne? So sulfur here, it's going to be plus 4. Okay? So let's check sulfur this side now of the products. Ne? Side of the products, it's sulfur plus 4 into -2. This should be equals to -2, right? So sulfur equals to 4 times -2 is -8. Then -8 transpose, it will be positive 8. So positive 8 minus 2 is plus what? Plus 6. Okay? So you can see it's from S4 plus to S6 plus. So you can see there's an increase in oxidation number. So if there's an increase in oxidation number, it means that your S4 plus becomes your what? Your reducing agent. There's an increase in oxidation number. It means that the substance is being oxidized, is losing electrons, and the substance that loses electrons is S4 plus here. Ne? Right, so this is going to be what? Reducing agent. So you can see your 2.4, 2.5 was a bit challenging. So those are some of the questions that you'll get. So you must be able to determine or to assign the oxidation numbers correctly and from there you will be able to determine which substance is the oxidizing agent and which substance is the reducing agent, which substance is oxidized, which substance is being reduced, which substance is gaining electrons, and which substance is losing what? Electrons, just by using the oxidation numbers, right? Then there are questions here. I think it's 3 of them. Good day. Will the table 4A and 4B be given to the examination? Do you have... No. There's no need, learners, to memorize table 4A and 4B. You will be given the table 4A and 4B. We are going to deal with that next week. Ne? Right, so but you should know that you will be given 4A and 4B. So there's no need to memorize. You can't memorize that table. Even teachers, they cannot do that. So there's no need. So you'll be given that table, right? Number 2, how to prove reactions using the half reactions on the data sheet. So we are going to deal with the half reactions next week. So please make sure that next week you don't lose or you watch us so that you'll understand how to do that. Ne? Then 3, how can I tell that the oxidation number of elements, how can I tell oxidation number of elements in the periodic table? So in the periodic table, I did that. Elements in group 1 is +1, group 2 +2, and then from group 3 to what? To 12, the oxidation number varies. Ne? So in most cases, when they ask questions, they will ask you to give the oxidation number of those transition metals. Ne? But for elements in group 13, which is Roman figure 3, or can say group 3, right, which is Roman figure 3, right, the oxidation number will be +3. And then group 14, where there's carbon, +4 -4. Group 15, where there's nitrogen, is -3. And then group 16, where there's oxygen, is -2. Group 17, where there's chlorine, fluorine, is -1. Group 18 is what? Is 0. So that was the question. How can I assign the oxidation numbers using the periodic table? So use those charges. Okay, right. So I think for today, learners, it's enough. We have looked at the oxidation numbers. What is oxidation number? The uses of oxidation numbers, how to assign the oxidation numbers, those rules, and how to determine the oxidation numbers. So those activities that we were looking at and those examples that we were looking at. And then oxidation reduction in terms of electron transfer, in terms of oxidation numbers, oxidizing agent, reducing agent, a redox reaction. How can you tell that this reaction is the redox reaction? So those are the things that we're looking at, and also identifying the substance that is being oxidized, substance that is being reduced, or oxidizing agent and reducing what agent, using the oxidation numbers, right? So next week the focus will be table 4A and what? And 4B, for us to be able to give oxidation half reaction, or half reactions, which is your oxidation half reaction and your reduction half reaction. So thank you so much for watching this lesson. See you next week.